Audio Jungle. Audio Jungle.
Hello everyone, myself Narendra Singh Maurya. So guys, today we have first lecture of aircraft performance, and the chapter name is atmosphere. So first of all, what is the atmosphere? That question is, what is the atmosphere? So as we know, if I'll draw the diagram here, so better we'll have understanding. Earth, and this Earth is what? Surrounded by gaseous elements. Okay, surrounded by various. It's like an envelope. Okay, it is surrounding. Earth is surrounding by gaseous envelope. All right. So whatever the gaseous envelopes here is surrounded around the Earth, this is called atmosphere. This is called atmosphere. So it is very true. It is very true. If we go from the Earth's surface to at any certain altitude, okay, at any certain altitude, it will have a different characteristics. Suppose this is what any other one altitude h1, this is what h2, and this is what h3, and here we know h1 greater than h2 greater than h3. So that characteristics is what will be changing. Okay, once altitude increasing from the surface, so that characteristics of the gaseous elements, you can say that properties will be changing. Properties in the sense pressure, temperature, density, that uh, properties will be changing. All right. So now basically the atmosphere is the gaseous envelopes surrounding the Earth, as I have shown to you. Okay, and its characteristics are different throughout the world. That is also correct, because whatever in, like in your city, what is the density of the gaseous elements, whatever it is surrounding to the Earth may be different, and to different city if you go, that will be different. For that reason, you know, like temperature, pressure, everything is what changing. So it is not same as you go from Earth surface to any altitude. Definitely thermodynamics property will be changing. That is one thing. Second thing, whatever the characteristics of the gaseous envelopes which is surrounding the Earth, that will also throughout the world will be different. Okay, for this reason it's necessary to adopt an average set of condition called international standard atmosphere. Okay, because from Earth surface to sea level somewhere different. Even in India only, if you go to the railway station, and also one yellow board you may have seen many times, I think, where they will mention from sea level, this is the level of the platform. From sea level, this is the level of the platform. For different station, different cities, it is different sea level. Okay, so in that time it is not very easy to give one constant what is the sea level value. So for that reason we have taken average set. Okay, and it is called average set of conditions, which is called the international standard atmosphere. Okay, international international standard atmosphere. This is one organization, and this is the standard for all the countries, for all the places. Okay, what will be the pressure, what will be the temperature, what will be the density, that will be decided for the sea level by the ESA, International Standard Atmosphere. That will be a standardized atmospheric value. Okay, it will be the standard value for all. I mean, if you are here in India, that sea level value, whatever you are taking, the same thing they will be taking in another country like Australia, USA, UK, whatever. Okay, for that reason it is called International Standard Atmosphere. So this is one organization, they have given one proper value like for the temperature. Okay, so whatever the value I'm writing here, it is sea level. Okay, and this is the constant for all, like temperature. Okay, and sea level value will be denoted by naught quantity, so temperature will be T naught. What is the sea level temperature? It is 15 degrees Celsius, or in Kelvin to 288.16 Kelvin. Similarly, we have a pressure. What is the pressure? It is P naught. What is the value here? 101.325 Newton per meter square. Okay. Similarly, we have a density, which is nothing but rho naught, 1.2256 kg per meter cube. Yes or no? Similarly, dynamic viscosity, I must write this. These are the properties. Okay, it is mu naught, and this value is nothing but 1.783 into 10 to power minus 5. Okay, kg meter second. And kinematic viscosity, it is nu naught, which is nothing but 1 point. So these are the constant value. Okay, need to remember sea level condition. Okay, and then characteristics gas constant. Also you need to remember R, which is nothing but 287.26 joule per kg Kelvin. So these are the constant value you need to remember. Okay, if you go for the atmosphere at sea level, so that composition, basically that is standard compositions are oxygen in percentage, generally it is 21%. Next composition is nitrogen. This is the nitrogen, how much it is? 78%. Okay, and third one is the, like in 1% what comes, it is like carbon dioxide, CO2. Okay, hydrogen, carbon monoxide, it is 1%. Okay, so now we understood what is the ESA, International Standard Atmosphere. Now we'll go for the different altitudes. So first we'll talk about the altitudes what we are taking. Once you go for the calculation, then we have a different altitudes called absolute altitude, absolute altitude. Next is geometric altitude. Geometric altitude. And third is the geopotential altitude. Geopotential altitude. Okay. Now, one by one, we'll see what are the different altitudes. So first, I will say this is absolute altitude. It is denoted by HA. What is the absolute altitude? Suppose this is the Earth, okay, and this is the center point of the Earth. Somewhere, if you are measuring the altitude, okay, from the center of Earth, you are measuring the altitude from the center of Earth, then it is called absolute altitude. Okay, it's measured. Okay, it is measured. Okay, it is measured from the center of Earth, called absolute altitude. Next one is the geometric altitude. Geometric altitude. It is denoted by Hg, and here we have Earth. Okay, this is the center. Radius is what? Re, and from any altitude, if you are measuring, so the altitude measured from the sea level. See, this is the sea level. This is called Hg. So it is measured from sea level. Okay. So what is the relation between absolute and geometric altitude? Absolute altitude is what measured from the center of Earth, which is nothing but HA. And what is the geometric altitude? It is measured from the sea level, Hg, plus if you are going to measure absolute altitude, it should be from the center of Earth. So what is the center of Earth? Obviously radius will be same for all. So means from all the places of the or you can say circumferential distance from the center will be same, which is called radius. So if you calculate what is the absolute altitude, so it will be Hg plus that radius of the Hari. Okay? So this is the relation between absolute altitude and geometric altitude. All right. This is the relation between absolute altitude and geometrical altitude. Now, next is the geopotential altitude. Okay, which is nothing but only H, denoted by H. So always remember the geopotential altitude is nothing but geometrical altitude corrected for the gravity variation. Okay, so I must write here it is nothing but geometrical geometric geometric altitude corrected for gravity variation. I mean, as well as altitudes will increase from the sea level, that gravitational acceleration will change. That you know in 10th standard physics. If you have corrected that variation of the gravitational acceleration, okay, that then whatever the geometric altitude, it will be the geopotential altitude. Okay, you can say in geopotential altitude that gravitational acceleration will not be varying. It is corrected. I mean, you have assumed okay, there is no variation in gravitational acceleration once altitude increasing. All right. So these are the different of types of the altitudes. Now we'll go for the analysis of the different layer in atmosphere. So I have to mention here different layers in atmosphere. What are that? First one, troposphere. Okay, first one is the troposphere. It is varying. Okay, this is the one zone. You can say it is varying from sea level to sea level to 11 kilometer. Okay, from sea level to 11 kilometer. This is called troposphere. In the troposphere, what will happen? Temperature will be changing, pressure will be changing, density will be changing. If I am saying changing means what? It is increasing or decreasing, so I have to mention it will be decreasing, it will be decreasing, it will be decreasing. Okay, so here temperature is what falling. So that fall of temperature, okay, fall of temperature with respect to altitude is called lapse rate. Okay, it is denoted by L or lambda. What is L? It is fall of temperature or change of temperature. You can say dt divided by with respect to altitude, dt by h. T is the temperature and it is fall, hence you can say minus t. L is equal to minus dt by dh, or you can say minus t by h. Okay, what is the value? It is 0.0065. Temperature unit is Kelvin standard per meter, or it is 6.5 Kelvin per kilometer. Remember, this is very important notes. Okay, So lapse rate in troposphere is the fall of temperature with respect to altitude is called lapse rate. It is denoted by L or lambda. So you can write L is equal to minus dt by dh or minus T by h. That value you need to remember. I have mentioned lapse. Lapse means automatically it is considered as a decrement. So no need to write a negative value with magnitude. Like here I have written 0.0065 or 6.5 Kelvin per kilometer. So here if you will not mention negative also okay. Why? Because it is mentioned in word lapse rate. Lapse means decrement. I hope you understood. Similarly, we have another layer. Okay. Another layer is nothing but stratosphere. What is that? Stratosphere. Okay. Always remember this is the zone where temperature is constant. That's the reason it is mentioned stratosphere. Stratosphere. Word is stratosphere. Okay. Can say strato means it is static condition. There is no variation in temperature. So this is the one zone. Okay. This is the one zone where temperature must be constant. So first of all, I will write what from where is stratosphere. So it is start from starts from 11 kilometer and it will go up to 50 kilometer height. Okay. Most of time it is considered till 20-25 kilometer. All right. But the starting point of the stratosphere will be 11 kilometer where troposphere ended. From there only stratosphere will start. All right. What will be the temperature here? Constant. Pressure changing. Density changing. Okay. Constant. What will be the constant temperature here? It is the temperature at 11 kilometer. What you have calculated at 11 kilometer, the same temperature will be there. So approximation I'm just giving to you. You can calculate. I will give the formula also, derivation. So you can take that value. Here I am giving that it is minus 56.5 degrees Celsius. Okay. You can convert in Kelvin. It is around 216 Kelvin. All right. Changing pressure changing. So in changing what? Increasing or decreasing? So obviously there is the fall, decrement. Similarly density also decrease. Okay. So these two zones, basically troposphere and stratosphere, were useful for us because our aircraft, max commercial aircraft, max to max will go to 8 to 10 kilometer, 11 kilometer. Okay. Like in stratosphere, if it will fly, then 11 kilometer, 12 kilometer, not more than that. If you go for fighter, some to up to some extent 20-25 kilometer, 30 kilometer, not more than that. So for that reason only, these two atmosphere layers basically or zones are important. Being aerospace aeronautical engineering, engineer, not aerospace, being aeronautical, your aircraft will fly in most of troposphere and stratosphere zone. But being a aerospace engineer, you may have a study of space shuttle, rockets, and all. So you will go more than this stratosphere, troposphere zone, obviously, because you want to uh, launch the rocket and space shuttle or what. So definitely it will go satellite and all. It will go till 500 kilometer from the Earth surface, 600 kilometer from the Earth surface. So definitely another zone also will come, that is called mesosphere. Mesosphere, okay. And this is mesosphere, basically it starts from 50 kilometer and it will end to approximate, I'm saying 80 kilometer. That is called mesosphere. Fourth, ionosphere. Ionosphere, it is start from 80 kilometer and it will go to 500 kilometer. Similarly, another layer, it is called exosphere, that is the outermost layer. Exosphere, it starts from 500 kilometer and it will extend above 500 kilometer. That is called exosphere, which is also called upper atmosphere. Okay, it will have a low pressure and density, no doubt about it, because as well as you are going from the sea level in upward direction, so pressure and density will be decreasing up to some extent. Like in stratosphere, the temperature will be constant. From troposphere it will be decreasing, but in stratosphere it becomes constant. If you go in above the stratosphere, in mesosphere and all, so temperature again it will start increasing. Okay, so these are the things. Here, the analysis of temperature, pressure, and density will be in troposphere and stratosphere, not in mesosphere and ionosphere and exosphere, because that is not our zone to study. It is beyond the our field, like aeronautical, because our aircraft and all, it will fly in troposphere and stratosphere. It is not going in mesosphere, ionos, or exosphere. So we no need to study for it. Just for information, I have given the zone. That's all. All right. So as I have mentioned, pressure, temperature, density variation. So in troposphere and stratosphere, so that variation we need to calculate by the formula. We have formulation for this. So we'll see. As we know, we have a, because aerodynamic force is just like a thrust force or buoyant force. Okay. So if we'll go the calculation of pressure, temperature, and density in troposphere and stratosphere. Yes or no? So governing equation we need to write for this. governing equation for pressure, temperature, and density in troposphere and stratosphere. Okay. What are the governing equation? Number one, it is called buoyancy equation. Okay, or it is also called hydrostatic equation. What is that? dp is equal to minus rho g dh. Yes or no? Comes from p is equal to rho gh, if you remember. So what is the dp by dh? Minus rho g. This is hydrostatic equation. Up to some extent in aerodynamics, it should be called as a buoyancy equation. Yes or no? This is equation number 1. Why minus sign? Because as well as altitudes increasing, pressure decreasing. That's the point. Okay. Altitude increasing, pressure decreasing, hence it is negative sign. This is equation 1. What is the second equation? That is called equation of state. States, or it is also called gas equation. Basically, ideal gas equation. What is that? P is equal to rho RT. P is equal to rho RT. Yes or no? Like you heard PV is equal to MRT. So from there you will get P is equal to rho RT. This is equation number 2. Okay. Combine this equation 1 and 2. Combine this equation 1 and 2. So we have P is equal to rho RT. Okay. Now, what is the rho? Rho is nothing but P by RT. Okay. And what is the first equation we have? That is dp by dh, which is minus rho g, equation 1. So what you can write? Minus rho is nothing but P by RT into G. Sorry. So ultimately what we got? We got dp by dh is equal to minus P by RT G. This is the very useful equation for the derivation of pressure, temperature and density in troposphere as well as in stratosphere. Okay. Now, anywhere you can start. Suppose if you want to start troposphere, so first we'll go calculation of pressure, temperature and density in troposphere. So first is the troposphere. Okay, which is from sea level to 11 kilometer. Here I told you that variation of temperature, that troposphere temperature will be varying and it will decrease. I have mentioned here. Okay, it will be decreasing here. See, temperature. So this temperature, it will be changing, right, and it will be varying. Obviously it will be decreasing, but that variation will be linear variation. Okay, in lab experiment, various experiment calculation and all, if you collect data, then you may get that temperature variation will be linear. So one, we can assume one linear equation which is nothing but like a linear equation variation. We can assume what is the equation: y is equal to mx plus c. This is the linear equation. So it is just like a, if this is the temperature and this is the altitude. So there is the fall of temperature, right? And it should be linear. So it must suggest this will be the fall of temperature, and that is the linear also. Yes or no? With different altitude. Suppose here this is the sea level temperature. Check, this is what sea level temperature, which is nothing but 15 degrees Celsius. So it is falling. Okay, it is falling means it is decreasing. So from 15 degrees centigrade to, it will come to 0 degrees centigrade, then it will have a negative some minus 20 degrees Celsius, and it is falling now. Okay, so at sea level temperature is what? T naught. So I must say, if you uh, write the equation, so C will be the constant, which is nothing but sea level temperature, which is nothing but T naught. M will be the slope, okay, and X is the axis variation, okay. So here M slope is nothing but lapse rate, which is nothing but L, and X is the variation, but here variation is the H, altitude, so that is LH. Instead of M, which is nothing but slope, so you have lapse rate, which is the slope, okay. Here if you say the slope, what is the slope? That is dt by ds, which is nothing but L. And variation, one variation you have taken temperature, another variation you have taken altitude. So obviously one is nothing but y, which is the variation of temperature. So I must say this is variation of temperature T at any altitude. Similarly, in x variation, here I have taken altitude variation, which is nothing but h, and this is negative. Why? Because slope is negative. So ultimately you got T is equal to T naught minus LH. This is the temperature variation. All right. I mean, see, y-axis here it is h, and x-axis it is t. But in our case, what we have taken, it is just reverse. X-axis we have in our this diagram, x-axis the temperature, but here x-axis we are taking altitude. I mean, if you redraw the diagram, so this diagram will come like this. So there should not be any confusion. This should be the temperature and this should be the altitude. Now it will be fine. If altitude is what increasing, so temperature will be falling. Now this is the correct diagram. Okay, for this analysis. Now it is fine. I have given just for understanding. This is the correct diagram for this. Altitude increasing, temperature will be decreasing. Just suppose it. Done. Now, so what is the temperature T here? It is T naught minus LH. What is dt by dh? It is nothing but minus L, because T naught is constant. Agree with this? Now we'll go for the derivation in troposphere. So what we have in troposphere, we have checked, it is nothing but standard dp by dh is equal to standard equation, governing equation dp by dh is equal to, what is that governing equation? This is valid for both. I must write this. This is the valid for troposphere and stratosphere. This is the governing equation. Okay, governing equation means what? It is valid for both. So dp by dh is nothing but minus p by rt into g, minus p by rt into g. Yes or no? What we can write? dp by p we can write is equal to minus g by rt, okay, into dh, that you can say g by rt into dh is nothing but what? Minus sign is there, minus L. dh is equal to dt by air. Sorry, I need to correct here because, wait, sorry, here I made mistake. Let me correct. One more steps need to write, I think. Okay. Check. What is the, see, what is the dh from here? dh is nothing but what? Minus dt by a. So you can keep here dh is equal to minus. Now it is. Finally, what we got? dp by p is equal to minus minus plus now g by rl dt by p. Agree? Now I can say this is the earth. Okay, so from sea level to, this is what h1 sea level, and this is what h2 at any altitude. This is nothing but dh. Similarly, at sea level T1 is the temperature, but sea level temperature we are taking T naught, and at any altitude, at H altitude you are taking temperature T2. Similarly, this is what pH is equal to P2, and P2 is equal to, sorry, P1 is equal to T naught here. Similarly, density at any altitude rho h will be rho 2. Similarly, density at point 1, which is nothing but sea level density, rho naught. These are the points you need to remember. What we got here, it is dp by E is equal to g divided by RL. Take it is constant, dt by, we have to take 1 point here and 2 points here, 1 point here and 2 points here. What will get? ln, you have to integrate and put the limit, g by RL ln T2 by T1. Remember, T1 and T1 is nothing but T naught and P naught. Okay, or ln by ln P2 by P1 is equal to ln P2 by T1 to whole power g by RL. Yes or no? Or you can write P2 by P1, take into log. P2 by P1 is equal to, what will have, T2 by T1 to whole power G by LR. Agree with this? Check properly. It's very simple only. Nothing is tough. You can check by your own. It's simple only. Yes. Or you can say it is pH. pH means at any altitude pressure. pH. P1 is nothing but P naught. T2 is nothing but TH at any altitude temperature. T1 is nothing but T naught G by LR. What is G by LR? G is nothing but 9.8. L is nothing but lap rate 0.0065 into R is nothing but 287.26. If you solve this, wait, I will calculate 9.8 divided by 0.0065 divided by 287.26. It is nearby 5.248. It is 5.248. Approximate you can write 5.25. Okay. So this value will be Ch by T naught to whole power 5.24. All right. So pressure you have calculated. What is the pressure variation? Ch by T naught is equal to Ch by T naught to whole power G by LR, or Ch by T naught to whole power 5.25. Now we'll go for the density variation. How to get density variation? What will write? P is equal to rho RT. We'll write P2 by P1 is equal to rho 2 by rho 1 is equal to T2 by T1. RR cancel out. What is the rho 2 by rho 1? It is nothing but T2 by P1 whole into T1 by T2. Yes or no? What is the P2 by P1? Just now you have calculated. Okay. T2 by T1 into whole power G by LR. T2 by T1 into whole power G by LR into, this is what, T1 by T2. So what will be rho 2 by rho 1? It is T2 by T1 to whole power G by LR into T1 by T2. Same thing I have copied. So this is what, T2 by T1 to whole power G by LR into T2 by T1 to whole power minus 1. But I can write rho 2 by rho 1 T2 by T1 to whole power G by LR minus 1, or T2 by T1 to whole power, what is the G by LR? It is 5.25 minus 1. T2 by T1 to whole power 4.25. Means rho H by rho naught is equal to TH by T P naught to whole power 4 point. This is the density variation. Now we'll go for the stratosphere. What is the stratosphere? Temperature must be constant, and stratosphere will start from this is the troposphere, and this is what stratosphere. The stratosphere start from H1, and this is what H2. H1 means what? It is data at 11 kilometers. Yes or no? So whatever the T1 you have to take, it is T1 at 11 kilometer. What is the T1 you have to take? You have to write T at 11 kilometer. What is the rho 1 you have to take? It is rho at 11. This is now again, what is the governing equation for this also? Same, I told you one governing equation I had given. Yeah, dp by ds minus p by rt. So here we have to write dp by th minus p by rt into g. Yes or no? Okay. dp by ds minus p by rt into g. What is the T here? It is a stratosphere. Ts. Ts for stratosphere. Stratosphere, which is constant. It is not going to change. But we can write dp by p minus g. R is constant. T s is constant. Stratosphere temperature is constant into ds. If you integrate this 1 to 2, what you will get? ln p2 by p1 is equal to nsg by rts h2 minus h1, or can write g by rts h1 minus h2. Minus sign you take outside, minus minus plus. What do you got? ln p2 by p1 is equal to g by rts h1 minus h2. What is the p2 by p1 then? It is e to power somewhere you may get like this exponential. What you may get? Exponent, no? Or e to power, meaning it will be same. It's your choice what you want to write. In calculator, in different way we are writing. It is nothing but exponent of g by rts h1 minus h2. It's your choice. So at any altitude it is ph, and p1 is nothing but 11 kilometer, is equal to e to power g r t at 11 kilometer. H1 is nothing but 11 kilometer minus h2 will be your altitude. This will be the stratosphere pressure variation. Now we'll go for the density variation. What is the density variation check? P is equal to what? Rho R T. So rho 2 by rho 1 is equal to P2 by P1 into T1 by T2. Yes, this is constant. Yes or no? This is constant. So rho 2 by rho 1 is equal to P2 by P1. What is that P2 by P1? E to power G by RTS H1 okay, or rho H by rho at 11 kilometer is nothing but E to power G R T at 11 kilometer. It is 11 kilometer minus H. This is the density variation. Hope you understood this. Okay. Now troposphere, and this is what? Stratosphere. We'll write one by one. Temperature, pressure, density. Check what is the temperature, how to calculate at any altitude. Ph is equal to P naught minus LH. What is the temperature here? It is 11 kilometer, which is nothing but constant. We need to find at 11 kilometer what is the temperature, and it will be constant throughout the stratosphere. What is the pressure? Ph by P naught is equal to Ph by P naught to whole power 5.25 you can say. Similarly, density rho H divided by rho naught Ph by P naught 4 point. What is the pressure here? It is Ph by P11. How much? E to power G RT 11 kilometer. Then here you have to write 11,000 meter into H. Okay. What is the density at any H altitude? Similar. So this is the whole thing what I wanted to deliver in today's session. Sorry, next session we'll have a numerical. Meanwhile, you guys keep practicing the derivation, try to learn the formula. Thank you all.